All right, guys, today we're moving on to 10.2a, which is area of triangles and trapezoids. And again, our mission is pretty simple, pretty straightforward with the title. I can determine the area of triangles and trapezoids. So again, we said yesterday when we talked about rectangles, squares, and parallelograms that the formula that we were going to be using, again, I know in times past in grade school, maybe you used the old area equals length times width. But we said we're going to kind of transition ourselves to more of an area equals base times height. And again, this height, just by way of reminder, is perpendicular height. Okay, so it is perpendicular to the base, and that's pretty important when you get to parallelograms. But it's important when you get to other figures as well. You're going to kind of see that today. But I said yesterday that we're basically going to build on this as we move through these different figures. Okay, so again, this is really important because even when we get into volume, which is actually going to be our next chapter, is going to be surface area and volume. When we talk about those things, we're actually going to use a version of this in that as well. Okay, so once you kind of understand this one formula, area equals base times perpendicular height, you're going to be using that for quite a few things. Okay, so let's go back. Yesterday we talked about the old square. And when we're talking about a square again, it has four right angles. So we know then that those heights over here are going to be perpendicular. So we know that right away. We also know that we have four congruent sides. Okay, when we talked about a square, we said, and that matter of fact, this applies to a rectangle as well. But we said that the area equals the base times the height. Okay, and so I want you to just think about for just a second, well, how in the world can we apply area equals base times height to now a triangle? Okay. So what I want you to think about is really a triangle is nothing more than half of a square. Okay. Again, as long as we have that perpendicular height, then this is still my height and this is still my base. The only difference is now I'm not looking at the entire surface, but I'm only looking at half the surface. Okay, so you can see how that when this is for a square or for a rectangle or for a parallelogram, etc., that we can then make the transition when we're talking about triangles to this formula, which is just built on this same concept that area equals 1/2 the base times the height. The other thing I want you to see about this is that this between the half and the base, there's also multiplication everywhere here. Okay, so I want you to keep in mind that multiplication is commutative, and you'll kind of see what I mean as we get ready to get into this here in just a second. But I want you to understand that this is commutative, so that means it can move around. Commutative, the root word of that is commute, which means that it can move. Okay, so let's just dive in. I think that's probably the best way to look at this. So if we're looking at a particular triangle, and again, sometimes they will give you more information than you need. So let's say that is 10 inches. And let's just say, for example, this is 9 inches. One again would be tempted to just take 10 times 9 and multiply that times half and work that all out. But again, this 9 is the length of this side. But notice that there is no indication that that is a perpendicular height. Okay. So again, what they will typically do is they will typically come down through here and make a dotted line. And you're going to find that little 90-degree box right there, that right angle box. And let's say that this particular height here is 6 inches. Again, we're just kind of throwing out arbitrary numbers. Okay, what I want you to realize is when we're talking about triangles, we've got area equals 1/2 the base times the height. That again, my base is going to be my bottom, and it's going to be the side that has a perpendicular height to it. Okay, so when we're looking at this 10 would have to be my base, not the 9, because it has a perpendicular height that is attached to it. Okay, this then would be my height, not the 9. Again, the 9's just kind of there for extra information if I'm being asked area. So again, I would have area equals 1/2 the base, which is 10, times 6, which is the height. Now, I want to show you that there's 3 different ways that you could really go about this, or maybe even more. But I want you to think about the fact that, again, because this is commutative, I can do this a bunch of different ways. I could just take 1/2 times 10 times 6, which would be 60. And so then 1/2 of 60 would be 30. And again, we need to put our units inches squared. Or I could think about this being 1/2 times 10 and then multiply that times 6. Well, that 1/2 of 10 is 5. So 5 times 6 is, in fact, 30 again. So you notice we're still getting the same answer. Or you could even say that I'm going to take 1/2 of 6 and multiply that times 10. So 1/2 of 6 is 3. 3 times 10, again, still gets me to that answer of 30 inches squared. So you can see that it doesn't really matter which way you go. To me, I like to work with smaller numbers because those are easier to try to figure out. And so I would immediately take like 1/2 of 10 is 5, 5 times 6 is 30, and I'm done. Okay. So this would probably be my one of choice, but it wouldn't really matter. Again, you could think about this any way that your mind kind of tells you to go. Okay. Now, similarly, you're going to have the same type situation that we had the other day where they're going to give you the area and they're asking you for a side. So let's just look at an example of that real quick. I'm trying to make sure that I give you examples of what everything you're going to see. So let's say we have 11 centimeters here. And here we do not know what the height is, okay? But the other information they're giving us is that the area is 77 square centimeters, okay? So let's just think about this for just a second about how in the world we're going to figure this out. Again, the height is what I'm really looking for because it's giving me the base. The base, again, is connected to my perpendicular height. So the base is 11 centimeters. Now, how am I going to find the height? Let's think about our formula. Area equals 1/2 the base times the height, okay? So let's go ahead and fill in what we know. And that's why, I always encourage you to write the formula out and then just fill in what we know. Area is 77. We know that the half is there. It's kind of like a constant in the formula. And then we know that our base is 11. And then we do not know what the height is. So here's all the information that we're given so far. Now, I don't know about you, but taking half of 11, that seems hard, seems difficult. So it doesn't really look like something I want to try to do right now. And obviously, half of height, but I don't really know what the height is right now. But remember, there is multiplication between all these things here. So one option that I could do really quickly is I could go ahead and just divide by this 11 on this side. And if I do it to this side, I have to do it to the other. And that will get that 11 out of my way. It'll get it away from this side. Again, my goal is always to try to isolate the variable, and this happens to be my variable right here, h. So if I divide by 11 on both sides, I'm going to end up with 77 divided by 11, which is 7, equals 1/2. Again, this is kind of canceled out now, and I'm left with 1/2 of h. So you might be thinking to yourself, well, how in the world am I going to get rid of a half? Okay, so remember this half is being multiplied times h. So if somehow I could, through division, well, I could divide by 1/2, but dividing by a fraction, let's just think about that for a minute. So when I divide by fractions, really I multiply by the reciprocal. So think about what you're really doing. You're taking 1 divided by 2. Well, a way to get rid of this fraction, this 1/2, is to multiply this entire thing by 2. Let me get me a different color. So I'm going to multiply this entire thing by 2, but if I do that, I have to also multiply this side by 2, okay? Let's think about what that does. So 2 times 7 is 14, and 1/2 times 2, or 1/2 of 2, is 1. It just becomes 1, and anything times 1 is just itself, right? So really, in essence, this half goes away, okay? And this 2 goes away as well. 1/2 times 2 is just 1. So all it leaves me with is just h, and h equals 14. You can see we very quickly get to that answer. Now you might be thinking, well, I don't know if that really made sense or not. Well, let's see if we put h at 14 back in for h, if it actually works out. So area equals 1/2. Our base, remember, was 11 times 14, which we now understand is our height. Here's our answer. Well, let's just work it out. So again, this is commutative. So I could go ahead and just take 1/2 times 14. and then multiply that times 11. Well, 1/2 of 14 is 7, and 7 times 11 does in fact equal 77, which was my original number that I really started with right here. Okay, so this would be my answer right here. H equals 14. Now let's move on to trapezoids, because this again, you're thinking to yourself, well, why in the world, Mr. Hamilton, would you group trapezoids with triangles? Well, let's just think about this for just a second. Again, my art skills, they can definitely use some practice. But again, I've got parallel lines here. And that's really about all I'm given. I'm given this trapezoid here, and I know by these parallel lines that it has to be a trapezoid. And so I think about this, and I look at this, and I'm thinking to myself, well, how in the world could I use area equals 1/2 the base times the height? How can I use this formula for a triangle to help me with a trapezoid? Well, again, just a few minutes ago, we took a square and we drew a line in it, and we said, okay, a triangle is half that of a square. Well, let's see if we can do something similar right here. So watch what happens here. What if I do that? Now all of a sudden I want you to notice that I really have two triangles. And again, you may not be able to see it as much, but just imagine if you were to take this and you were to cut it in two with a pair of scissors and you were to flip this thing over. Okay, think about what you really have now. What you really have now is you have a triangle that looks like this, and then you have a triangle that looks like this. And again, if you were to flip it over, it would end up looking exactly like we already had right here. So really, a trapezoid is nothing more than two triangles. It just so happens, though, that I don't have the same base on these triangles. So think about this for just a second. I could call this base 1, and I could call this base 2, right? Once I flip it over, this becomes my base, and this is the base on this one. So again, really a trapezoid is just two triangles. The issue is, though, where in the world is my height? I don't really have a height yet. Here's what I want you to consider. If I make a height down this trapezoid, and ladies and gentlemen, this height is the same for this triangle and for that triangle. They both share the same vertical height because I have parallel lines here. So let's just kind of break this down into something maybe that we can formulate into a formula that we could use. Think about this for just a second. I'm using this basis for a triangle and the fact that I'm given two triangles when I'm really looking at a trapezoid. So think about what our area is of a trapezoid. I really have 1/2 of base 1 times the height, which would give me the area of this guy, okay? Plus, I have 1/2 of base 2 times the height, which would give me this area here. So notice if I take the area of the first triangle and add it to the area of the second triangle, then I basically have the area of the trapezoid. But we need to try to make this even easier. So what I want you to notice here is I want you to look for a GCF, a greatest common factor between this two sets of terms, okay? Look for a GCF between these two sets of terms. And if you notice, they both have a 1/2, and they both have a common height. Remember that this height is the same for both of these triangles. So they both have a common height. So I'm going to pull those out as a GCF, as a greatest common factor. And now the only thing left over is B1 plus B2. That's the only things left over in my equation is these things right here. So guess what, ladies and gentlemen? This is how you find the area of a trapezoid. You find the area of a trapezoid by taking 1/2 of the height times both bases added together, okay? So it's just that simple. Let's go into a couple of examples here. One, we're going to be finding the area. The other one, we're going to be given the area, and we have to find the other. So let's take an example of this. And again, this is my formula that I'm going to use. So I'm given something that looks like this. And 7 centimeters and 12 centimeters. And they're telling me that the vertical height is 6 centimeters. Okay. So again, I could call this one base 1. It wouldn't really matter which one's which, again, because it's commutative. And this would be base 2. So it kind of looks like the mid-segment stuff we did before. But again, area equals 1/2 the height times base 1 plus base 2. Just based on the fact that it's 2 triangles, all right? Don't let it confuse you. This formula that we just developed is just based on the fact that we've really got 2 triangles. So we have area equals 1/2 the height, which is 12, times base 1. I'm sorry, the height is not 12. Mr. Hamilton made a mistake. The height is 6. Base 1 is 12 plus base 2 is 7. Okay. So we have 1/2 times 6 times 19. Okay. So again, think about what's easier to do. I don't know about you, but in my head, I cannot do 6 times 19. Okay. So, and half of 19 is going to be some kind of decimal number. So the easiest thing for me to do is just to take 1/2 times 6. So 1/2 times 6 is 3. 3 times 19 is going to give me 57. Again, you may have to grab a calculator. That's fine if you have to do that. But again, we're just trying to get these as quickly as we can. Again, thinking about ACT, you've got 60 minutes, 60 questions. So the more speed that you can gain, the better off you are. So our area for this trapezoid is 57 centimeters squared. Okay. One last example before we go today is I want to look at one where they're going to give you the area and you have got to try to figure out what the side length is. All right, so we're given this is 130 centimeters squared. I'm told that this is 16 centimeters, and here's my question mark that I don't really know. So you notice it's like, well, wait a minute, they didn't even give me my area, but notice you're always looking for this squared symbol right here. Anytime we're talking about area, it's going to be squared. So you want to look for that being raised to the second power to tell you that, okay, wait a minute, they're giving me the area. So again, let's write that formula. Area equals 1/2 the height times base 1 plus base 2. And again, let's just fill in the information that they're giving us. They're telling us the area right here is 130. I'm not really worried about my units right now. I'll put my units back in here in just a second. All right, 1/2 is always there in my formula. My height, let's just think about this. Again, this would be my bases right here. Okay, so I could go ahead and label this maybe as base 1. This is base 2, what I'm really looking for. So this has to be my height right here. 10 has to be my height. So base 1 would be 16. Base 2 is really my question mark that I don't know. Wow, let's kind of look at this and just see what we need to do here. There's a couple of different options. I could take this 10 and I could distribute it through everything and then try to do half of everything that's there. That seems complicated. So let's just, the 130 is going to stay the same over here. And just think about what's easy. It's easy to get 1/2 of 10, right? 1/2 of 10 is going to be 5. And I'm still asked to multiply that times 16 plus B2, which I don't know yet. And again, I could use an option here. There's always options in mathematics. You can always go different directions to try to solve, but the end goal is still the same. I need to isolate that variable right there. Well, again, I could distribute this 5 through. I don't know what 5 times 16 is right off the top of my head. So I'm thinking about doing this a different way. And what I want you to think about is this 5 is being multiplied times all this, right? There's a kind of an unseen multiplication symbol right there anytime a number is right beside of a parenthesis. So actually what I could do at this point is undo this 5, and that would leave just this over here by itself. And that may be the easiest course of action to go. So I'm going to divide by 5 on both sides. So 130 divided by 5, and again, you may have to grab a calculator for that, would be 26. But notice what happens, what kind of magic happens here. These 5s go away, And now all of a sudden, all I have left is 16 plus B2, okay? So in order to get this B2 to itself, this other base that I'm looking for, then all I need to do now at this point is just subtract 16 from both sides. And that leaves me with B2 equaling 10, okay? So this would be my other side length. And again, it's not just 10. I guess I should have wrote that a little bit different. B2 equals 10 centimeters, okay? I'm not going to put centimeters squared because I'm not looking for area. I'm actually just looking for the side. So remember, the side length is always going to be, it is not going to have anything squared, but if we're talking about the area, it is going to be squared, okay? So that's what you would do on that particular problem there. And hopefully this won't be too difficult for you. I think you're going to be able to do this pretty easily and simply. Next time we're going to be talking about rhombuses and kites, okay, which are, again, kind of based on triangles. But we're going to keep expanding this definition right on along, okay? If you need help, make sure to reach out to me or Miss Wheeler, and we'll be glad to try to help you as well.